So um, I'm going to tell you about developing or how to start developing for mixed reality and what is mixed reality and how to start developing for mixed reality with HoloLenses and what this device is about. But let me first introduce myself a little bit. I'm Rafał Legiędź. I'm from Poland. You can find me on Twitter at Rafek. I'm a software engineer at the company called Solid Brain. It's a software house in Krakow, Poland. And for last like 1 year, I'm mainly focused on HoloLenses and augmented reality. I speak with different businesses. I create different proof of concepts for this technology. I'm trying to convince some businesses that this technology is something they would like to invest in, that this is the future, and I'm actually trying to show that the technology, I mean, augmented reality and augmented reality on goggles can actually improve your performance, can actually earn you money, etc. So that's my main focus, and that's something I'm focused on within the company I work for. Also, I am a conference organizer. I organize a conference called DevConf. It's in Krakow. We're doing it since 2011, so it's 8 years now. It's in September, so if you would like to visit Krakow, that's a good opportunity to visit the conference as well. And also, I try to be a conference speaker, so whenever I think I have something interesting to say, I apply to conferences, and hence I'm here, for example. And I talked a lot about HoloLenses during last year, and Microsoft decided to award me with MVP award, so I guess that's a cool thing to do. Okay, anyway. Around HoloLenses and in general, VR and AR are a pretty common thing. There are a lot of discussions around it. There are a lot of articles on the internet that VR is the future, AR is the future, or whatever. So what I would like to do in this slide is to differentiate, to explain what is the actual difference between those two technologies or those experiences, because there is still a lot of confusion out there. So VR stands for virtual reality, which is basically the experience where the user puts the headset on, and it occludes the user's vision, and the user is fully immersed into digital environment. So everything the user sees is fully synthetic. And those devices, those experiences are designed in a way so that the user's mind is being tricked into thinking that the real world basically doesn't exist. Right? How many of you have tried before, like Oculus Rift of HTC Vive? Like half of you. So you already probably know how immersive, how convincing the experience is. For those who hasn't tried it yet, I strongly recommend trying. Probably you can do it in plenty of places right now. And if not, you can also see on the videos on YouTube people trying VR and how they freak out when something external from the external world touching them or something like that. It means this experience is really, really convincing, and the user really thinks that the real world doesn't exist. On the other hand, we have AR, which stands for augmented reality. As the name says, we are augmenting the world here. So usually those experiences are on mobile devices. That's the most common way they're delivered right now, on our mobile phones or tablets. So those experiences usually use the camera lenses of our phones, and whatever the users see on the screen, whatever the lenses see, it's being displayed on the screen, and then some digital content is being overlaid on that screen. Sometimes AR devices come in the form of goggles or glasses, like HoloLenses, so they're more fancy than, the experience is more immersive. So where are HoloLenses? Are they VR or AR? But because this is the question I usually get from people. So if we would think about our world like there is a physical world and a full digital world, where the physical world is the one we interact with on our regular daily basis, and digital world is like when everything is rendered. We have the whole spectrum of experiences that we can get between those two, I mean, spanning those two extremes. And those experiences depends on the kind of device that we are using, on the kind of software that we are using on those devices. So most of AR devices, they lay very near this physical reality. That's because most of them, as I already mentioned, runs on our mobile phones or tablets. So the user isn't fully immersed into this experience. The user is still fully aware that the physical environment is around him or her, and the digital augmentation only occurs on that screen. So it's not very convincing. Some of them devices are a little bit more sophisticated. So, for example, some kind of glasses like Google glasses or any other, or some phones with some more some better sensors, for example. And on the other hand, on the digital reality end of the spectrum, we have all the VR experiences and devices that we have on the market. That means that whenever we are using VR, we are completely not aware of physical reality. So digital reality is the center of the experience. So HoloLenses are somewhere here. This is basically the device that is an augmented reality device, but the design, the hardware that is inside, the thing that it is a head-mounted display as well, it all combined gives a better and more convincing experience to the user. Everything that the user see, well, that depends on the application actually, but usually all the users see can seamlessly blend with the environment, can interact with our physical things as well, so that this immersion effect in HoloLenses is way better than on any other AR platform out there on the market. So that's why it spans a little bit more of this spectrum, because this digital content that is delivered on this device is more convincing to the user, and that it actually appears in that physical world. On the other hand, it's worth to mention that what Microsoft did recently, which is mid-October last year, they released a bunch of mixed reality headsets. Those are regular VR headsets like Oculus Rift or HTC Vive, but the difference with the other ones is that they employ a little bit of technology from HoloLenses, which means inside-out tracking. That means that those new VR headsets, they do not require external sensors for movement, for tracking the head and controller's movement. So they are easier to set up and they're easier to use than Oculus or Vive, for example. And also they work on the same platform as HoloLens, which means Windows 10. And that's what's mixed reality, and that's why Microsoft nowadays, that's why they use Windows mixed reality term a lot, because they're trying to create one big common platform for VR and AR experiences, which they named mixed reality. And what Microsoft is trying to do, I think what they're trying to do here is that they're trying to fill the whole spectrum with the devices, or one ultimate device that will be able to deliver all kind of experiences to the user. So HoloLens, what's that? That's this device. How many of you have already seen this, the device? Not many of you. For most of you, it's a very new thing, but it's it's been announced, I think 2 or 3 years ago. I think it was 2015 when they were announced, so it's quite a while. It's a device made by Microsoft, and it was released in mid-2016. I think the first wave of devices was shipped to developers in June 2016. So it's been a while since they are on the market, and actually there are a lot of companies and lots of developers that are leveraging this technology, and they're delivering real apps for that, and they are solving some business cases, or just improving performance at some companies with that. And what else I can say? It's it's an independent device, so it's untethered. You don't need any cable or any external computer to run it or to power it in any way. So it's a PC desktop in there, right? Self-contained. So this is a big plus because that's the only thing you have to take with you. It runs Windows 10, which might be good or not, depends if you like the system, but what it means is that it's not any closed system or anything exotic, it's just Windows 10. And we program applications there as we would be programming for Windows 10. So basically we could use Universal Windows Platform or just Unity for anything 3D. Okay, so whenever the user puts the headset on, it's not occluded. It might seem as it's occluded, but we can actually see through it. So we see our physical world through it, and we fire up the applications, any application, and then all of a sudden we have some digital content rendered around us, which we can interact with or we can place whenever in our environment, and it looks like this. So we have to have this device on to see the holograms. That's how we name the 3D objects that are being displayed in our application. We name them holograms in this case. So there are lots of scenarios which I'm going to tell a little bit more later, but this looks basically like this. One of the coolest features of HoloLenses is that, as you can see here, there are two people wearing HoloLenses, is that we can have an application that can be fired on two HoloLenses or more, and they can communicate with each other like any multiplayer game, I would say, because the mechanism under the hood is the same. And those users can see the very same holographic world around them, so they can easily collaborate on some content, and they can work on a piece of 3D thing being rendered in front of them. So this is pretty cool, and this is what most of the companies are asking for nowadays when it comes to HoloLenses, collaboration. But let's talk a little bit more about hardware. So to make all this magic happen, we need a lot of sensors, of course. So right in front of it, on our forehead, we have a bunch of sensors. To make long story short, we can say that this is an enhanced Kinect device being attached here to the glasses, but it's a little bit more than that. We have 4 environmental understanding cameras. Those cameras are responsible for scanning users' environments. So they gather information about where are the surfaces around the user. I mean, where is the floor, where are walls, where is the ceiling, where are the chairs, etc. So they scan the environment all the time. We have RGB camera. We have mixed reality capture sensor, which allows us for streaming whatever the users see to an external computer, or record videos or making screenshots. Also, we have four microphones which are there for voice commands, and there are 4 of them because the device has to make sure that the voice command comes from the user itself, not the person standing next to it. And there are some other sensors like depth sensor or ambient light sensor. The difference here is when it comes to Kinect, because that's the most common question as well when it comes to sensors. Lots of developers ask if we can get a raw stream of data from a depth sensors, which was possible with Kinect. And in this case, Microsoft didn't get us access to that, so we can't use raw depth sensor data. The other thing is to display those convincing holograms. We need a set of really cool displays in front of our eyes. And to be honest, I haven't delved into this particular technology. How are they done? And this is not important here. What's important here is that they can render 3D objects in a way that you can feel if they are nearer you or further from you. And the resolution is pretty okay as well, because there are 2 HD engines, 1 per each eye, which means it's 72p per eye. The other thing is the brain, which is holographic processing unit. This is a coprocessor specially designed for HoloLenses, and this is the processor that processes all the sensory data that comes from all the sensors. So all the environmental understanding data, all the gesture recognition or voice recognition, all comes from this, and then is being transferred to a regular processor. When it comes to the rest of the hardware, there is 2 gigs of RAM, 60 gigs of SSD storage, there's Bluetooth, there's Wi-Fi. There are, of course, batteries that last for 2 to 3 hours of active use, and the regular processor, which is 32 bits, which might be surprising because like most of devices we have, mobile devices we have right now are usually 64 bits, but in this case is 32 bits. So how do we interact with our applications? I mean, there is no mouse, there is no keyboard, so we have to have a way to interact with whatever we see. There is something which is called GGV input paradigm, which means gaze, gesture, and voice. Those are main ways to interact and issue commands to whatever we see. So gaze is, this is very similar to how it's done in VR. So basically, we have a cursor in front of our eyes, and this cursor follow our gaze. So it doesn't follow our pupils, it follows our gaze. So we need to actually move our head to move the cursor. So that's our cursor. So we can imagine this as a laser being attached to our forehead. So whenever there is whenever we're looking at something with a head movement, the cursor moves with our head. The other thing is our gestures. We point some things with a cursor, with our head movement, and then if something is focused, based on where our cursor is or where our gaze is, we can issue commands. And one of the way to issue command is by gestures. So the sensors that are being here tracks our hands. They know when the hand is in the area where the gestures can be detected, and then they can detect gestures. So for developers, there's basically one gesture to handle, which is this. This means air tap. This is like catching a fly or pinching. And this is the only gestures that we can handle in our application. There are no custom gestures. We can't program anything custom, which is a good thing in my opinion, because just imagine like every application you would run, you would have to have a tutorial about what gestures are available in the application, and first you would have to learn all of them, and then you would be able to use the application. So that makes sense in some case. In most of the cases, of course. So based on this gesture, we have several gestures derived, I would say. The one is hold gesture, which is like half air tap, and the other one is manipulation or navigation gesture, which is also like hold gesture, and then we can move our hand, and then we can just track the hand movement, and that allows us for different interactions, like for example rotations or resizing. The other way to issue commands to our application is by voice. So basically we can program voice commands. The only language available here and supported is English, but it makes things a little bit easier when we can just look at something and just say something, and something will happen. Okay, so based on that, as I mentioned before, there are lots of companies that already are leveraging this technology. Lots of things are happening on the market, and just to name few examples. And I mean, there are way more than that. You can Google it. You can Google HoloLens, manufacturing HoloLens, medical apps, HoloLens, whatever, and you can probably find lots of examples in every industry. So this is Citibank. They made trading application for the traders, so basically they can visualize trading info in real time, and they can manipulate those data and interact with them in that holographic world, and they can share actually whatever they see, they can share to other user with a tablet or computer. Ford recently announced that they're employing HoloLens to their design processes, so they can talk about new designs of their cars or design them with this device. And this is where the collaboration thing is happening as well. Schneider Electric, they are doing application for service workers. So whenever the service worker approaches some piece of machinery that he or she is going to do some maintenance work on, there can be like instructions being displayed in front of the eyes, and literally they can show steps to perform on the machine to complete the task. And for all of those, you can actually find the YouTube videos and see how those applications work. So this is, I think, one of the most common scenarios: maintenance and manufacturing, where apps for service workers or field workers are delivered for HoloLenses so that they can perform better in those tasks. Tyson Group, the company that specializes in creating elevators, they also have an application for service workers. So whenever the worker needs to do any maintenance work on an elevator, he or she can get lots of contextual information just in front of the eyes, like manuals, video tutorials, or video manuals, or they can perform a Skype call, or just see in large 3D model of an object that he or she is going to perform some maintenance task on. But any other, I mean, there are other experiences also. Those experiences, they don't show one of the coolest features of HoloLenses, which is spatial mapping. This is what happens when we put the data gathered by environmental understanding cameras into use. I know this doesn't say much, but if you blur your vision for a while, you will see it. This is a model of the room. This is a mesh of the scanned location. So as I mentioned before, HoloLens and environmental understanding cameras, they scan user environment. They gather that data about all the surfaces that are around the user. I mean, not all, usually those surfaces that are 3 meters, I mean, up to 3 meters in front of the user. So to scan the whole room, we have to walk around a lot. But from the moment the HoloLenses are turned on, they start scanning the environment, and we can't stop it. Well, we can't disable HoloLenses, we can turn them off, but whenever they turned on, they scan. So it doesn't matter if there's any application running on them or not. We do not program it. It's there. It's on an operational system level. And based on the location, HoloLenses, they detect where they are based on some location features, and then they update the model, underlying model of this location all the time. So for example, if I would just turn them on, and even if they would be just laying like that, they would gather whatever they see in front of them. And this is cool. We as the developers, we can make use of this data. We can program against a specific API to get to this data and create the models. And that's one of this model. This is the very simple application where basically I visualized whatever is being gathered by the device. So whenever there was a surface, I just rendered the white grid, and that's it, right? So for example, for this room, it would be basically the model of this room, but whenever we have a surface, it would be visualized as this mesh. This is not very exciting. This is only for visualization, that the room is scanned. But the more exciting thing is that with all those meshes, with with the model of the location, we also get colliders. And colliders are objects that are invisible, and what they provide is all the physics mechanics to our applications. So we can imagine that whenever we have a surface, like a real surface in our physical world, we have a nicely aligned collider within our application. So whenever we have some 3D object in our application, we would drop it on the floor, it would hit the collider that is being aligned with the floor. So the effect would be like we have a virtual ball that bounces of the physical floor. And that's where this immersion is elevated to a level that is really convincing. So those are examples of free games available for HoloLenses. I mean, those are not all games that are available, but three most advanced ones that they show how to leverage the device to a full extent. And we can see in those games, I mean, I really recommend playing them. It's Young Conquer, Fragments, and Roborate. So in one of it, we can have like virtual characters that basically they run on our physical floor, jump on our bed, on our table, they fight with each other, they bounces on the floor or walls. Fragments is the game where your room becomes a crime scene, so you have to find clues which are hidden, actually hidden in your room. You have holographic characters coming into your room, and they can actually sit on your physical sofa. This is really convincing stuff. And Roborate is about an alien invasion. You have aliens that are drilling through your walls and attack you, and those damages to real wars are pretty convincing as well. This is one of the best games as well. So if you'd like to try one of those, just find me after the lecture. I have a device with myself. You can try it. Okay, I have to speed up because I have some code to show you as well. So to develop things to this device, we usually use Unity and Visual Studio. And that's because it's Microsoft things, so we have to have Visual Studio here, apparently, and C# under the hood. But yeah, but Unity is the most common one. You don't have to use Unity. You can use C++ if you like, and DirectX. You can use Unreal Engine as well. But the vast majority of community gathered around this technology, and Microsoft itself, they support Unity, and that's basically the technology that you would like to use, because I mean, in other way you would be probably by your own, basically on the internet, using anything else. So we use Unity for setting up our scene, to program, to put together 3D objects. We use Visual Studio for writing scripts and building and deploying the application. There is one problem with Unity. There are a lot of versions. They are releasing new versions like crazy recently. And apparently, Universal Windows Platform is not their main focus. So from version to version, they break stuff. So if you would like to start developing for HoloLens, just don't go with the newest version of Unity. You have to go with one like 10 versions ago, because nowadays, whenever Unity releases new update, they usually break something that used to work and introduce some fix to something that used to not works, and vice versa. And that's pretty insane nowadays. And there are lots of patch releases as well, and there is a beta release as well. So just don't go with the newest one, because you would have like lots of problems, seriously. There are on a Holo developers Slack, there are lots of discussions around that, and actually we are wondering if Unity even care about that. But well, that's some issue that probably is going to be solved anyway. And to speed up our development, we have two open source libraries released by Microsoft. One is Mixed Reality Toolkit. It used to be called HoloToolkit, and this is just a bunch of scripts and ready and objects or assets for Unity that wrap some Unity stuff and deliver them to us in a more digestive way, I would say. I mean, all the developers that started developing HoloLens applications at the beginning, of course they noticed some patterns in what they were doing, so they just wrapped it up and released as the open source library, and it's still well maintained, and it's being updated all the time, so it's pretty cool. And the other one, Mixed Reality Design Labs, it's also open source library with well, they're focusing on components, and there are two applications there as well, like games, which is open source, and you can just download them and see how things should be done. You can treat them as a reference thing to do your stuff. And there are some components, ready components there as well, like buttons for AR or bounding boxes, etc. All of them are available on GitHub, so you can find and download them from there. Okay, demo time, I guess. Are there any questions to whatever I've said so far? If not, I will just fire up Unity and we'll show you how to create simple application. Oops, I have to. Wow. Can I switch to mirror? Okay, let's try it. Okay, so Unity, it looks like this. Have you ever seen this IDE? Okay, so it's probably something new for you. How to zoom it? Okay, so this is Unity, one of the newest ones, and that's why I have lots of problems with that as well. But it looks very similar to other IDEs for like 3D design or where we create 3D scenes or animations. But if you're not familiar with that, I'm going to just quickly go through the how IDE looks like and what's where. So here the main thing is the scene view. That's where we put up our scene. That's where we put the objects. That's where we construct the whole experience. This is the hierarchy view. That's basically all the objects that are in our scene. They're here aligned with some kind of hierarchy. Here's project view. That's where we have all our assets that we are using in our solution. That's here. And here is an inspector pane on the right. That's a pane for whenever we have some object in our hierarchy or project pane selected, we have properties here being displayed. Okay, so that was long story short. What I wanted to show you is how to create like a Hello World application, which is using Mixed Reality Toolkit, so that you will see that to deliver really simple application like rendering some kind of an object in front of the user eyes and placing it on the floor, detecting the floor and placing it on the floor, is really easy. And what's more, it's usually what businesses usually ask for at the very beginning. So whenever I'm talking with any business, any new business, any manager at some companies about this technology and how we can start working on it and start solving some companies' problems with that, we usually start with like simple proof of concept. I usually get some kind of a CAD project or some piece of machinery from them, and I have to just display it or place it on the floor or whatever, or just resize it or just make it rotate or whatever like that, just to give them understanding how the model would look like on those glasses, and then we iterate over this kind of simple application. So to start things, as I said, we're going to use Mixed Reality Toolkit. I already imported it. It's under the name HoloToolkit here. You just download the package from GitHub and just import it in Unity, like this, import package, custom package, and that's it. I'm not going to show you how to do it right now, because that takes a time and we don't want to waste it right now. But it's imported, and right now I have all the components that are in the packages available to my application. I have them organized in folders which are named after the purpose of those components, right? So if I would like to program gestures or gaze or cursor, I just go to input folder and just grab some ready-made objects for those interactions. But first, I have to configure, I have to tell Unity that I'm going to create HoloLens application here so that Unity knows how to build the application and that it has to target universal Windows platform. So under mixed reality menu, I have configure, apply mixed reality project settings. So what I have to say is that I'm targeting universal Windows platform, I'm enabling mixed reality, I'm building for direct 3D, and I have .NET scripting backend. I'm just applying it. And it should work. Okay. That's all. In my build settings, whoops, I have to add my scene. So whatever I'm designing right now, I'm adding to the build. And also, as we are going to use our special data gathered by HoloLens, I need to ask for a permission. It's like asking for like internet connectivity permission on mobile phones or anything like that. I need to ask for permission, give me access to spatial perception data. That's a basic configuration. Now I can just start putting things together to achieve the effect. So camera is a component that that gives us that shows us, I mean, that's the target where all the rendering will happen. So whatever the camera sees will be the end result that the user will see and will have rendered. The default camera is not appropriate for HoloLens, so I'll just delete it. And there's a ready-made component in HoloToolkit, which is called HoloLens camera, which is well suited for HoloLenses. I'm just dropping it here. I'm gonna use gestures because what we're gonna do in this application is just we're gonna load some external model and we'll just write a script for like placing it on the floor and rotating it, as simple as that. So we're gonna use gestures. So there's input manager for gestures. I'm gonna place it here. We would like to have a cursor, which are done here. Cursor is for visualizing gaze. So whenever we'll be looking at something, we would like to have a little dot or a ring rendered at the very end. And as simple as that, without writing any single line of code, I have my simple application, which I think I can run. That's it. You see, we have a cursor. This cursor is a blurred dot, which means we are not hitting any object because we don't have any object here, but we're visualizing our gaze here. And with the HoloToolkit components, I have a support for a keyboard within Unity, so I can use WASD keys to navigate and to move within that application, and mouse for looking and creating and issuing gestures. So the whole toolkit is really handy thing, so that we do not have to leave Unity editor for debugging. Okay, now we would like to make use of our spatial data gathered by the HoloLens. So I need a component for spatial mapping. Oh, come on. Which is called spatial mapping. And well, my computer, it doesn't have sensors. It doesn't know what room we are in, so we have to provide some kind of a model of the room for our debugging purposes. So I have a model of the room because what you can do with HoloLens is you can scan a room, you can get to HoloLenses with your IP address of the HoloLenses, I mean through the browser, and basically you can download the model of the room that you're in, like download the model, and then you can import it in Unity, and it will serve as a model for the application. But that's only for debugging purposes. So I have one of those already done, and I can import it. It's under default room, and okay, that's frustrating. And I'm just dropping it here. And bam, I have my room here. Can you see it? That's that's a simulation of the room. That's basically a 3D object. That's all. That's nothing special. That's only a bunch of triangles that looks like a model of the room. So right now we can see our cursor, which is here. It's now a ring, not a blurred dot. That means we're hitting some surface. We're hitting some colliders, so that the user experience is better here, so that the user knows where exactly we are looking at. So now we would like to look at the floor or whatever and create issue an AirTab gesture, and then we'd like to render some things. So first, I'm going to import some object. I have created a forklift object for this demo. So I'm just going to import it. Okay. So let's create that script. To have scripts running within our Unity application, we have to have some object to attach the script onto it. So this script for like placing a thing in our environment isn't bound to anything particular, any physical object. I mean, any virtual object in our application. So I'm just going to create empty object here, and I'm just going to name it. System, and having this object selected, I can add component to this object, and I will just name this component placement behavior, and that's going to be a script. Having this done, I can edit the script by double-clicking it, and it should open me Visual Studio. That's right. Okay, I'll make it bigger. Okay, can you see it? Is it good or bigger? Make it like that. Okay. So we have to add the possibility to handle the gesture. So having Mixed Reality Toolkit in place, we can just program against some interfaces instead of going through Unity API and subscribing to some events, etc. Mixed Reality Toolkit nicely wrapped this for us, and to handle AirTab gesture, we simply have to implement input click handler. Oops. And this interface has only one method to implement, which is on input clicked, and this is going to be invoked whenever the device detects that we're doing this, right? As we do not have anything on our scene and we do not point at any particular object when we are performing this gesture, we need to say to the application that this gesture is kind of a global gesture, so that it's not based on some focused object. To do that, we just need to tell input manager that this object that we are programming, the empty game object with this script, which is game object, is going to be a global listener. The funny thing is that lots of things in Unity and Mixed Reality Toolkit are singletons. So that's, if you're an enterprise developer, that might be something unusual here. And we're trying, as enterprise developers, we're usually trying to avoid this. But in Unity, we have lots of singletons. So that's something you have to get used to whenever programming for Unity. So okay, so whenever we're issuing an AirTab gesture, we would like to detect if we're looking at the floor, and if we're looking at the floor, then render something. So first we need to get information about where actually we're looking. So there's this one, there's one handy component for that, which is called Focus Manager. Of course, it's a singleton, but with this Focus Manager, that's a component from Mixed Reality Toolkit. Get focus details. We can get focus details where of the user's gaze. So based on gaze, whatever gaze manager is giving us, so whatever the user is looking at, Just give us this point whenever we are crossing some virtual object. In our case, that's going to be the spatial mesh, right? So we can then, if we do have the details about this point where our gaze crosses the spatial mesh, then we can get all the coordinates and normal vectors from that point. So now, if we're looking on the floor or anything else, any other mesh, we have to detect if it's a floor. So if it's a flat thing, so we can check if the normal vector of this of whenever we are looking at is how much it deviates from the up vector, up normal vector, and based on that angle, we can say if something is a floor or not. So what I'm going to quickly do here is I'm going to calculate that angle from normal. Oops. Which means give me the focus details normal, which is normal in a point where we're looking at, and vector 3 up, so normal vector pointing up. So if this angle is like less than, for example, 15 degrees, let's say, that's only for demo purposes, then we can say, okay, it's a floor, okay? So if it's a floor, we can instantiate our forklift model. That happens with instantiate method from Unity. And that's going to be forklift. And that's where I will show you how dependency injection works in Unity. It's with public fields. And I will show you in a second. Okay, so we're instantiating forklift. And then we are changing its position to whenever we are looking. So whenever we are hitting that floor, that's the point where we would like to render this hologram. And as simple as that, I hope it will work. It should appear on the floor where we're looking at. We would like to also disable this spatial mesh so that we don't have those triangles around us. Spatial. Draw visual mesh is false. And also after the event is handled, we have to tell our event pipeline that we used this event so that it's not bubbled further. So as simple as that, we also have to define this forklift here. And given that, it should update here pretty soon. Okay, so I updated my script and fill in the properties pane. I can see a forklift thing here, and that's every public field on our script will be displayed here, and that's our dependency injection mechanism. So I can drag my prefab, my forklift prefab from here to here, and that's where the magic happened with dependency injection. So now, whenever I will look at the floor. Oops. Bam. I clicked on the floor, and now I have my forklift on the floor, right? Whatever is black here will be transparent on HoloLenses. So, I don't know how much time left I have. Probably it's... Is it done already? Okay. So, can I just show you one more script? It's a launch. Like 5 minutes, okay? Okay. So I would like to add one more script for like rotating the forklift. So I would have to add a script to this object that I'm using, which is forklift model here. So I'm just selecting this model here, and I'm adding a component which is a script as well, and I'm just gonna name it forklift behavior. And we're editing it. Come on. Okay. I have new script. This is attached. It's being attached to my forklift model. So I would like to handle manipulation gestures here. So I would like to be able to click on it and just move my hand like on the x-axis and then make it rotate on the y-axis, so it rotates like that. So for that, I need to implement an eye manipulation handler. And manipulation handler gives us ability to handle our hand movement. We have a bunch of methods to implement here, like manipulation cancelled, which we do not bother with right now. Manipulation completed, we do not bother with that right now as well. Started, also we don't bother with that. We have manipulation updated. That's where we will be getting the delta value of our hand movement, and that's what's interested for us. So here we're getting delta of our hand movement, which is in event data, cumulative data. And based on that delta, we would like to rotate our model. Our model is something that this script is attached to. So under our transform field, we have transform of our model. So we can rotate this transform on a particular axis. We would like to rotate it on an y-axis. So x-axis will be 0. Now we have to give some value for y rotation, which will be delta x. So our x of our hand movement would be translated into y rotation for the object. I have to place it minus here because of the values that are being given to rotate it in the correct way. And that's pretty much it. Let's see now. Okay, I'm missing one thing. My cursor disappears when I'm looking on the object because the object doesn't have a collider. So what I need to do is to find my object. And I need to add collider to it, mesh collider. And that's it. Okay, now the model has a collider in it, so my gaze collides with the object, and I can see my cursor being sticking to the with the object. And now I can just grab it, and I can rotate it. As simple as that. So as you can see, with a very little amount of code, like 2 lines here and several lines here, we can create very simple demo. But when you would create something like that and put it on your boss's or the client's head and show that this is something real and you can interact with this stuff and this stuff actually is in front of you, that's really convincing, and that's where lots of interesting discussions can start. I would deploy it to HoloLens, but I actually have it deployed. So if you would like to see it, you can approach me and I can show you this application on the HoloLenses, and I can show you any other. So now it's time for questions, I guess, if there is any. If not, just approach me after the session. I can show you some more within the device. Okay, I guess everyone's waiting for lunch. Cheers, thank you then.